All right, in this video, we are continuing section 7.3. It's about double angle and half angle formulas. Now I'm going to solve more examples of the double angle formula for sine and cosine. All right, if tangent is negative 4/3, what is cosine? This is very similar with the previous example I did in the previous video, actually. First of all, what is cosine 2x equal to? It's cosine 2x. And I have, as you may remember, there are three identities for cosine 2x. Cosine squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 cosine squared x minus 1. But the first formula has cosine squared x minus sine squared x. If you want to use this formula, it has then we need to find both cosine and sine. So this can be, time consuming. So instead of using that, I can just use the other two, one of the other twos, right? Because those other two formulas are not having both cosine and sine. They are just they are either having cosine or sine. So, for example, I can use this formula, right? Cosine 2x is equal to 2 cosine x, cosine squared x minus 1. Okay. So I can use this formula, and if I want to use this formula, I need to know what cosine x is. And the way to find what cosine x is, actually, I need to here tangent x, right? I know what tangent x is. So tangent x, so let me draw my picture again. And x is in the second quadrant, right? This is important. And tangent is negative 4/3. This is, let's say this is 4, this is 3, but one of them should be negative because I want to make tangent negative. And to decide which one is negative, you just need to look at which axis these parts are on, okay? This is negative x-axis, right? So this should be negative 3, all right? And again, of course, this is the right angle. And to know what cosine is, I need to know what hypotenuse is, right? I can use Pythagorean theorem and I can see that actual hypotenuse is 5, okay? All right, with having that, now what is cosine 2x? 2 times cosine x squared x. What is cosine, by the way? Cosine is adjacent over hypotenuse, right? Negative 3/5. But we are taking the square root of it, right? This says cosine squared minus 1. So this is actually equal to 2 times 9/25, right? Minus 1. 2 times 9 is 18/25 minus 1. And which makes, if I have the common denominator, 18 minus 25/25. And 18 minus 25 is negative 7/25. Okay. Same tricks as we did in the previous example. I just use the double angle formula here, and I need to find what cosine x is. To do so, I am just drawing the picture of it and see what cosine x is. Okay, I'm just drawing the triangle and finding cosine x and plugging what cosine x is and get the answer. Okay. All right. So let's look at the next one. Sine x equals 1/√5, and cosine x is negative. Find cosine 2x and sine 2x. Okay. To find sine 2x, I need to know what cosine x is, okay? So let's try to find what cosine x is first of all. How can I find cosine x? Sine x is, again, I can draw the triangle if that's useful. Or I can use the identity, right? The most famous trick identity, sine squared plus cosine squared is equal to 1. Okay, let me use the identity this time. So sine squared x plus cosine squared x is equal to 1, right? I'm trying to find what cosine x is because I need to know what cosine x is to find what sine of 2x is, right? In the double angle formula for sine, we have 2 sine x cosine x. So we need to know what cosine x is. Okay. And sine x is 1 over root 5. So 1 over root 5 squared. 5 squared plus cosine squared x is 1. So 1 over root 5 is 1 over root 5 squared is 1 over 5, right? 1 over 5 is 1 over 5 plus cosine squared x is 1. So if I subtract 1 over 5 from both sides, I will get cosine squared x is equal to 1 minus 1 over 5, which is, if I have the common denominator, 5 over 5 right here, minus 1 over 5, which will be 4 over 5. So cosine squared x is 4 over 5. So cosine x is, okay, this part is quite important, plus or minus, right? Root 4 over 5. And I can rewrite root 4 over 5 this way. Root 4 of root 4 is 2, right? Plus or minus 2 over root 5. But which one? It can be, cosine can be either 2 over root 5 or minus 2 over root 5. But in the question statement, it says cosine is negative, right? So I have to pick the negative value, okay? So cosine x is equal to negative root 2 over root 5. Cool. Now, let me move it here. So I know what cosine x is. So let's find cosine 2x and sine 2x. So for cosine 2x, remember we have 3 different identities, 3 different half double angle formula. I can use either of it. So let me use the one that has only sine it, because sine is already given in the question statement, right? So 1 minus 2 sine squared x. So that's equal to okay, that's equal to 1 minus 2 times 1 over root 5 squared, right? 1 over root 5 squared, 5 squared. So which is equal to 1 minus 2 times 1 over 5. Okay, 1 over square of 1 over root 5 is 1 over 5, right? And now 2 times 1 over 5 is 2 over 5. 1 minus 2 over 5, which is 3 over 5, right? If you had the common denominator, 3 over 5. Cool. We got what cosine 2x is. So let's find what's sine 2x. By the way, if you know what cosine 2x is, you can use the most famous trig identity to find what sine 2x is, right? But let me use the double angle formula to make you guys familiar with the formula, okay? So sine 2x is 2 sine x cosine x, okay? And what is cosine x? It's got 2 times sine x, 1 over root 5, times cosine x, negative 2 over root 5. So 2 times 1 times negative 2 is negative 4 over root 5 times root 5 is 5. So sine 2x is negative 4 over 5, okay? All right, I hope these are all exciting and clear. Now let's go to the double angle identity, double angle formula for tangent. And again, we are using the same, the sum formula for tangents. Remember tangent A, what is tangent A plus B is? Tangent of A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. But in the setup here, right, we have 2A, so it is tangent A plus A. So if you just substitute A for B in the formula that I just gave you, you will get this identity, okay? So my point to explaining this is you don't need to really memorize this if you want. you can just use the sum formula here to get the double angle formula. All right. Okay, let's look at this example. If secant x is root 5 over 2 and sine x is negative, find tangent to x. Okay. So first of all, so what is tangent to x, right? Let me write down what tangent to x is. Tangent to x. I'm just using this formula. 2 tangent x divided by 1 minus tangent squared x. Okay. So I need to know what tangent x is to get to find what tangent to x is. So what I know about x is secant is root 5 over 2, right? And secant is 1 over cosine. So from there I get 1 over cosine x is equal to root 5 over 2. So if you flip everything, we will get cosine x is equal to 2 over root 5. Okay, what is tangent x, right? I need to know what the tangent x is. So what is tangent x? So there are different ways, as always. You can draw the triangle, as I did in the previous examples, to get what the tangent is. Or remember, tangent is equal to sine over cosine. And I know what cosine is. So if I know what sine is, I can also find what tangent is, right? And if you know cosine, and if you want to know what sine is, you can use the most famous trig identity, right? Sine squared plus cosine squared is equal to 1. So let me use that. Maybe I can move up here. Okay. So sine squared x plus cosine squared x is equal to 1. Sine squared x plus cosine squared x. If I take the square of 2 over root 5, I will get 4 over 5, right? Is equal to 1. So sine squared x is 1 minus 4 over 5. And if you have the common denominator, it will be 1 over 5, right? So sine squared x is 1 over 5. So sine x is, again, this part is important, plus or minus, right? 1 over, so root 1 over root 5, but root 1 is 1, so I can just write plus or minus 1 over root 5. So this is what sine x is. So we have two possible values for sine, but which one? Which one should we pick? And if you look at here in the question statement, it says sine is negative, right? So I have to pick the negative value. So sine is actually equal to negative 1 over root 5. Okay, cool. So what is tangent, right? It's our main motivation. So what is tangent? Let me move the page up a little bit. So maybe I can do it here. Tangent is sine over cosine. And sine is negative 1 over root 5 over, and cosine is here, right? 2 over root 5. So I can simplify root 5, so I will get negative 1/2. Nice, we have a very nice tangent value, right? Tangent is negative 1/2. So now let's take this value and plug it in the formula here. So that's equal to 2 times negative 1/2 divided by 1 minus negative 1/2 squared. So 2 times negative 1/2, I can simplify these twos, just negative 1 over 1 minus, what's negative 1/2 squared? It is 1 over 4, right? So negative 1 over, if I have the common denominator here, it will be 3 over 4. And how do we do this division here, quotient here? Just flip the bottom and top multiply with the top, right? That's actually equal to negative 1 times 4 over 3. So it is negative 4 over 3. Yes, the answer is negative 4 over 3. Okay? So we just use the double angle formula for tangent 2x, I mean. In the formula, we need to know what tangent x is. So we know what secant x is. So using that information, we found what tangent x is, and now I just plug that tangent x in the formula and get the answer, okay? I hope it's clear for everyone. Okay, let me continue. Evaluate exactly if possible. 2 tangent 22.5 degrees, 1 minus tangent squared to any 2.5 degrees. And whenever you see such an expression, it will just remind us the double angle formula, right? So, okay, it's the formulas here, right? So in this formula, A is 22.5, right? That's why this is actually equal to tangent 2 times A, 2 times 22.5 degrees. And 2 times 22.5 degrees is actually 45 degrees, right? So that's equal to tangent 45 degrees. What is tangent 45? This is the special triangle, right? 45, 45, 1, 1, root 2. And tangent 45 is opposite over adjacent. It is just 1, right? So that expression is actually equal to 1. Okay? All right. This is all in this video, for this video. In the next video, in this section, I will do more examples, and I will also talk about the half angle formulas. So for now, let me stop here.